community. So I will start by giving you a brief presentation of the museum and also of the project. So then Antonio can give you more details of the intervention process. Well, Museo de la Solidaridad Salvador Allende is a very typical. It has a very unique and outstanding international collection of more than 2,800 modern and contemporary works, most of them from the 1960s and 1970s, although it spans until nowadays, which makes it one of the most prominent art museums in Chile and Latin America. It is settled in downtown Santiago in the building you see in the image since 2005, but its history goes back to 1971, when Museo de la Solidaridad was founded on the context of Salvador Allende's government, Unidad Popular. 675 works were donated in this first period of the museum from the countries that you see in the map, thanks to the enthusiasm and commitment of the International Committee of Artistic Solidarity for Chile members, all highly distinguished curators, art critics, and intellectuals from these countries who contacted artists they knew to donate in support and in solidarity with the people of Chile and the first democratically elected socialist government. Brazilian art critic Mario Pedrosa, who arrived to Chile in exile, was the president of the committee and head curator of the museum. And in the US, Dora Ashton, another outstanding art critic who wrote in the New York Times, was a member of the committee. Since the curatorial line of the museum was based on modern and experimental art, Ashton made a call for abstract and minimal artists in the US. Amongst them, Carl Andre, Robert Motherwell, and Frank Stella responded. Stella at the time was 36 years old and already had a major retrospective at the MoMA. His successful artistic career began in the late 1950s with his famous series of black paintings. He selected Isfahan 3 as the donation because, as he said, it was what he had at hand at that moment in the studio. The big format painting was made in 1968 as part of the Protractor series, a group of irregularly shaped canvases made between 1967 and 1970. The series, planned as a total of 93 pieces, was devised to include 31 canvas formats based on the multiplied shape of a protractor, each painted in 3 variants of compositions, named interlaces, rainbows, and fans. The title of the works in this series referred to cities and places in the Middle East. The title of the work belonging to the museum collection corresponds to the Iranian city of Isfahan and the third pictorial variant, fans. There. The work arrived in Santiago in 1972. Its canvas rolled up and separated from the stretcher, along with the donations from American artists. It was exhibited for the first time in Chile the following year in the second exhibition of the museum held at the Museum of Contemporary Art of Universidad de Chile, since Museo de la Solidaridad did not have its own venue yet. 1 year after the coup of September 1973, the work was transferred without its trainer to the new venue of MAC in Parque Forestal, where it was kept in clandestine custody in the underground storage rooms of the museum with the rest of the collection for 18 years. In 1991, after the restitution of democracy in Chile and during the process of recovering the pieces donated to the Museo de la Solidaridad that were at MAC, the great canvas by Frank Stella was found folded in a share. Isfahan 3 was presented again to the public at the reopening exhibition of the museum in Chile, held at Museo Nacional de Bellas Artes. sorry, this was the image, where it was displayed in a temporal stretcher, highlighted in the main hall. You can see there the canvas without the stretcher, how it was found on the left. Due to the loss of its original stretcher, in 1999, a new one was made to be able to exhibit the piece permanently in the museum. In 2007, an invitation to exhibit a selection of the museum's collection in Brazil fostered the creation of a new stretcher for itinerary exhibitions that was made in Sao Paulo in 4 dismountable parts. The 4 images on the right show some of the problems that this new strainer presented for Isfahan 3. None of them met the dimensions of the original, especially its 3 inches depth, and both were deficient in structural terms, too heavy and unstable. The structural and aesthetic deficiency of the last supporting version of Isfahan 3 impulsed us to present in 2019 this project to the Getty's Conserving Canvas initiative. It was developed jointly by our museum chief conservator, Camila Rodriguez, the second conservator, Elisa Diaz, art historian and registrar, Natalia Keller, Josefina Lopez, painting conservator, director and consultant of Conserve Arts in Santiago, with the collaboration of Antonio Iacarino and the guidance and help of Antoine Vilmering. Its main goal was to design and construct a new stretcher for Isfahan 3. Research on the artwork, the series to which it belongs, and its history within the collection was developed in parallel to the material analysis to have clarity regarding its formal characteristics, original materials and techniques used by the artist, as well as the vicissitudes it had lived through. We read and saw many of Stella's interviews and interviewed ourselves, conservators that worked with it before, the constructor of the 1999 strainer, and a specialist on Stella's work. Structured in 3 stages, the project included also both practical and theoretical workshops by international advisors for a group of 26 conservators and technicians in wood and stretchers specialized in modern and contemporary paintings from institutions in Santiago, Concepción, and Valparaíso from Chile, Buenos Aires and Rosario in Argentina, Bogotá, Colombia, and Sao Paulo, Brazil, who were invited to participate in weekly sessions during the months of August and September 2019 at the museum. In August, Antonio Iacarino held a workshop on stretchers, which allowed Chilean and South American participants to discuss and exchange proposals for the design and construction of the new strainer for Isfahan 3. One of the main contributions of this week-long workshop was to introduce and explain to participants how the innovative elastic tension system that he proposed to apply to Isfahan 3 worked. During the workshop, this system was applied to another painting from the museum collection by Italian Corrado Cagli, and to a mock-up of the central part of Isfahan 3 that was made to test its performance. During September, the second workshop was aimed at the analysis of the pictorial layer of the work and discussion regarding future treatments of pictorial cleaning and reintegration. That week of daily sessions was in charge of 2 specialists in Stella's work, Christine Froner, Associate Conservator of Contemporary Conservation Limited, New York, studio in charge of the artist's works, and Camila Corbella, Conservator of LA Art Labs, who works as an associate researcher at LACMA in Los Angeles. The workshop also included practical exercises in cleaning techniques, material analysis, and overpainting, which could be applied in the future to this work. Both, together with Iacarino and the Stella project team, delved together with the participants in a discussion regarding the pictorial layer of Isfahan 3, while taking into account the history of events suffered by this work and the formal characteristics of the series to which it belongs. All the professionals contributed in an active dialogue from their different expertise that was essential to successfully complete this project. In parallel to the workshop week held in September, the construction of the new strainer for Isfahan 3 was completed. It was co-designed by Yacarino and architect Daniel Ortiz, founder of Pro Fabrica workshop in Santiago, where it was constructed with the collaboration of Chilean artist Patrick Steger. In October 2019, Camila Rodriguez, Christine Froner, the museum director Claudia Saldivar, and myself interviewed Frank Stella in his New York studio to learn more about the original production process of the work, details of the original stretcher, and how it was built, amongst other things. I will present to you a very short cut from that interview filmed by Kathy Brew for the documentaries of this project, Bruno Salas, so Antonio can afterwards present Isfahan 3's process of interventions on behalf of the whole conservation team. Thank you. So this is.
And also, you know, nobody ever resolved the cuts that aren't, those were supposed to be ultimately rewoven. So you could fold and stretch it in correctly. Yeah.
Yeah. But you never did
No, we never got anybody to do that.
And you have also different systems of covering those spare areas, right?
Not really, no. I mean, they're not covered. I mean, yeah. And it's technically, I mean, in order to stretch it properly and everything, you'd have to cut it all the way into the crease and pull it.
Yeah.
So it won't be a perfect
That's
stretch.
the challenge now, when you have to restretch it always, right?
Yeah. But by and large, actually the size helps you in a way, because the crease, you have enough tension overall, so it doesn't.
And when
we didn't get real creases.
Yeah. And when those stretchers were built back then, how exact were they? Did you always have?
Well, I painted them. I mean, yeah, no, they were exact enough. I mean, but we stretched the canvas on it, and so we painted it on the stretcher.
Yeah.
So it fit perfectly.
There. Thank you. Antonio.
Can you see my screen? Okay.
Yes.
Yeah. Okay. So it was a beautiful interview. Basically, the problem we faced to start with was that we didn't have the original stretcher or strainer, because it's not an expandable stretcher, but a strainer, fixed strainer. So we got this image of the Isfahan 1 by Christine Fröner, and this helped us a lot to understand how we could possibly move towards the construction of a new stretcher. This is an interesting structure, because it's a one layer of plywood which is screwed to a second layer of plywood, and then there is a perimeter of cut wood on the sides, which makes the 3 inches thickness. So it's a very thin and flexible structure. So basically, what happens is that, as in a kite, you know, for flying, the canvas provides rigidity to the wooden structure, which is good if you're an artist, but is rather problematic if you're a conservator, because you're not really allowed to have the canvas give rigidity to the stretcher. So basically, we had to find a way to get a good compromise between the rigidity and the conservation. So I'm now started the description of what the whole group has done, and for the examination of the painting, and that was partially done during my stay in Santiago, but most of it was done by the group in Santiago alone. So this was the last stretcher the painting had, and it was made in Brazil, and it was rather problematic because, as you can see here, the meeting point of the two halves has always been a problem, and here you see that it's been expanded. So it was a cut, and then some wood was inserted, and then a screw was there for keeping it all together. But the wood was very thin, and so it broke in several points during the transportation and multiple installations. Also, the previous stretcher had been adjusted in shape because it was a complicated shape. So also here you see that it has been expanded, but also it has been adjusted on the side. I don't know if everybody can see it, but it's probably under the faces, everybody's face, but there is this part that was added on the right. So the tucking margins have had a very hard life together with the painting. And you can see that the lighter color wood is the Brazilian stretcher. This one is the previous one. And basically you can see that the painting has been stapled multiple times onto it, and even the wood has broken because of this. So some distortions had to be accepted, as we have seen from Carol's presentation. And this was one of the main concerns, and also, but we have learned from Stella himself that it's always been a problem. But during the time, the painting had changed its shape, and basically the first part of the life of the painting has been quite tough. And after stretching on one of the stretchers, the painting was even wet with water, so that in order to have the canvas to adapt to the form of the stretcher, in order to reduce the forms, the deformation in the three major problematic areas. So basically you see that these lines that were supposed to be vertical or 90 degrees from the horizontal had changed their direction. And this was not the only problem. So you can see here magnification of pencil marks, because the painting was done on a canvas, on a cotton canvas, which was not sized nor prepared. And first of all, Stella drew with a pencil, and then put some masking tape in order to leave part of the canvas bare, and then he painted with directly on the canvas. And you can see that this is a drop of the canvas, or the paint on the raw canvas on the side, and this is how transparent the paint looks, the painting and the paint look. And then there were quite a few overpaints, not very nice. And so some samples have been taken and analyzed, and the same for the canvas on warp and weft, and of the adhesive on the perimeter, because there were some, as you can see here, these were all patches that were glued with some acrylic adhesives on the perimeter of the painting, in order to restretch it exactly in the difficult areas or in the damaged areas. And you can see here that a lot of adhesive was left on the perimeter, and obviously under the patches. And there were some areas where the canvas was torn or damaged. So now we start the description of the treatment of the painting and of the making of the new stretcher. It's very important to remind that the whole group, it was a very good and very varied group, took part to the whole project. And so here we see that, okay, so some areas were reinforced with patches of silk with Biva film, and some areas have been treated by tear mending. And this is the removal of the patches in one of the concave areas. And you can see that the patches were not badly done because they were frayed, very deeply frayed. And but still they were, the canvas was much stronger than the original. And the whole thing was very stiff in the area. So it was very complicated. It took at least a couple of days to find the best way for removing the patches and the adhesive. And finally, one of the things that seemed to work best was to reactivate the adhesive in a similar way to Jos van Och's mist lining, because there was sort of solvent canvas laid on top of it with the plastic envelope in order to keep the vapors inside. And then it was not so difficult to remove the adhesive from the original canvas. Then you can see here areas in those concave points, areas where the canvas was very damaged, and there was need of realigning the threads with the thread by thread method. And then you can see that there was a Biva film silk patch reinforcement in that area. This is only one of the many places where it's been done. So you can see the dry mechanical cleaning of the rear of the canvas, of the rear of the canvas, and you can see here accumulations of eraser used for the cleaning. And then you can see here moments of the analysis of the paint layers and the old paints. And here you see under the microscope magnification, the green layer with some dirt particles on. And then we finally got to what I'm more interested in, which is the construction of the stretcher. So basically, the first problem we faced was to find the original, the existing shape, which is not the original shape as we have seen of the painting. So basically, the painting has been stretched on this beautiful table that's been prepared for the task, stretched with masking tape on the tacking margin, and as you can see, the force is going always outwards, perpendicular to the tangent to the curve. So it's been stretched and then carefully restretched the day after, so that it was really flat, and after the patches were removed, so that the shape was exactly the one that we needed to document for the construction of the new stretcher. So then you can see that there were many patches, points that were drawn on papers in order to find to evidentiate the lines that were needed to we needed to draw. But then we had many bending lines, at least two, and then this was the last bending line on the reverse of the stretcher. So it was a bit complicated. So for a while we sort of doubted which was the good line and which was the good approach for the construction of new stretcher, because the format changed, but we still needed to find something that could be considered right for the original. So basically, thinking about it and talking about it loud, we realized that Stella had used this 7 inches proportion for the outer pencil mark. So this was the guide for the construction of the stretcher. So we devised the right line on the 7 inches away from the pencil line, pencil mark, which is here. You cannot see it, but you can guess it. Here it's a bit more visible. And then we marked many points on the perimeter, and then we started measuring them like this. So this is a trilateration or triangulation system, and basically each point is identified by the position of other tools, because a triangle with fixed sides is cannot be changed. So it gives a very precise definition of the points, of the position of the points, relative definition. So basically, what we did was, first of all, we took the measures, and then we put them on a CAD drawing, and then we took verification measurements between other points which had not been used for previous work. There is someone who should be muted, probably. So with this drawing at hand, we started drawing the new stretcher. And so we had the idea of prolonging this connection bar, because it could be useful for giving more rigidity to the whole thing. And then we saw that there were corner braces to increase rigidity, and we decided to put corner braces on all the connections, but rounded, so that the whole thing would become more rigid. And then we had to use all the thickness we had. So the 3 inches needed to be used as a whole thing, because we didn't want to have the canvas collaborating too much, I mean, almost at all, to the rigidity of the stretcher. So the stretcher also needed to be disassembled in a similar way in four parts. Then with this first drawing, we made a first test of the shape on the painting. And then we started thinking of the real materials to be used. So as Stella was using plywood, we decided to use plywood. But then, as we needed to make a sandwich, we decided to test balsa wood inside the sandwich between 2 plywood layers. And then we also tried to make it more rigid with carbon fiber in between the balsa and the carbon, which did some work, but would have become very complicated to do it in the very short time we had. And it would make everything more complex to machine and everything. So we decided to leave the carbon, also because testing, as you can see, testing the deflection of the bars, we saw that the carbon was not working enough in order to add it into the sandwich. So we made a mock-up, a 1-to-1 mock-up of the central part, which we friendly called gaviota, which is a seagull, because it has wings like a seagull. And and then we started testing. As you can see, the canvas needed to be cut in strips in order to fit the rounded shape. So this is the construction of the stretcher, which was done with, as Carol said, with the collaboration of the whole group. But in this case, in this situation, Daniel Ortiz was very helpful, because he proposed to make balsa even lighter than balsa, because there is air in the balsa, as you can see here. There's a lot of air, So almost half of the balsa was taken away, and only the structural part was kept in place. And so the whole thing was designed in pieces with overlapping joints, and then cut with Profabricas machines and assembled. And here you see the assembly, and here you see the rounded sliding perimeter in plastic, which is a sliding plastic. So we see the arrival of the stretcher made by Profabrica, and here you see the carbon epoxy connection plates made by Equilibrarte in Rome. So we have a lot of experience in working with carbon composites. So we made them in Rome and brought them to Santiago. And now we see the elastic tension. Now I see that I don't have much time, so I have to go faster. The stretcher, the new stretcher was assembled, and it was very beautiful. And we liked it very much. And if it were not for these 7-plate carbon plates, it would look very much like Stella's. And then we placed it on the stretcher, on the painting. And this was the cutting of the frayed canvas for the edge lining. So this was all drawn in CAD, and then cut with Profabrica's laser cutters, and then it was glued with Viva film on the edges of the painting in order to make a very, very moving edge lining, because on the painting only one direction of the fiber of the canvas was glued. It was only the weft. And then you can see that the pockets were sealed, and then in the pockets there was a connecting steel bar, and that was connected to the springs. And you can see here the work we did on the gaviota, which is, you see here the connecting rod, which was bent by hand. And then the students were learning to use the springs, the participants, sorry. And then this is the painting. You can see the rod and the plastic perimeter. Putting the springs on hook and then adjusting the tension. The tension was adjusted for each spring, knowing the exact force that these springs give for the elongation. We could measure exactly the force that the painting was submitted to. So, and here you see the painting being lifted away from the table, finally, which was a very emotional moment for everybody after almost 2 months of work. And so here you see the spring optimization work that was done in collaboration with Luca Fattore, the mechanical engineer who collaborated to the group with the team of Exemplar in Torino. And basically the goal was that of reducing the compression forces in the concave areas, and that of reducing the amount of stretching the canvas would undergo because of its elastic behavior. So he launched the simulation. It was 90 goes, automatic, and then the simulator found a good proposal for the balance of forces. And this was the force equilibrium that the optimizator proposed us. And you can see that it's not so different. It's almost the same force. It's 117, 118, 125, 118, 122, 128. And this was because of the distance of the parts and the distribution of the force, but also this was because of the reduction of the compression forces in these areas, which would give ondulation. But we needed to measure the friction we had on the plastic perimeter, and we did it there on this simulator stretcher, which had springs on both sides. And here you can see the plastic element. And so liberating the canvas, we could measure the difference in force. So as the difference in force due to the friction was approximately 0.28 Newton, we augmented the forces by that. But still, we were far below dangerous forces. And this allowed to reduce the compressive strains in the corners to only 10% of what they could have been. Now, the painting is stretched with these forces, successfully stretched. There is practically no deformation anywhere. And the displacement sensors are in place, measuring the displacement of the canvas, of the painting on the side, which is all moving continuously. And there is one RH and temperature sensor in the center. And this is the painting now. And this was the beautiful group we worked with. And I'm very, very thankful to all this group and to the Getty and to Carol and to the museum for this wonderful experience. This was all for me.